Hello and welcome to 10.3 Notes on Shapes of Distributions. I'm your host, Mr. Boleen. We're going to look at data here. We're going to kind of determine if the data is skewed left, symmetric, or skewed right. This is probably the first time you're going to be hearing this vocabulary. Symmetric, though, kind of means what you would think. That means the bulk of the data would be in the center, the cluster, if you would, while skewed left and skewed right would have the bulk of the data either on the left side of the graph or the right side of the graph. And what's interesting about this one is that a lot of these questions are somewhat open to interpretation. My suggestion, though it's debatable, is that you lean towards symmetric as long as the cluster appears in the middle. Only skewed left and skewed right, kind of more if it's clearly that the cluster or the peak is on one of the sides. So let's take a look at the first one here. Clearly this first one on the monthly rainfalls, clearly it's not perfectly symmetric. If it was perfectly symmetric, this peak would probably appear right here in the center. But if you look at the cluster, which I would call these two, the cluster does include our middle number, our middle of 4. So I would lean toward this one being called symmetric, because the cluster does appear in the middle. Even though it's slightly shifted right, this would be symmetric. If we look at question 2 on the number of home runs hit, we should be able to clearly tell that this is not symmetric. The cluster appears over here. Okay, so that's called skewed. That means the data is not in the middle, it's skewed to one side or the other. Now the first time you look at this, you'll probably say this is called skewed left, but this is actually called skewed right. And you may think it's left because the data is on the left, but you can look at it's looked at it in actually the slightly different way. It's skewed right because the data tails out to the right. Or you can view it as, to make it symmetric, you need to move the data to the right. It could be viewed in either way there. So for a lot of people, it's the opposite of what they initially think it is. But hopefully those two explanations kind of give away what it's actually looking for. Let's look at the next one. Question 3 here, I think is a somewhat debatable one. You kind of go back and forth here. I really feel the cluster would be 2 and 3. Okay, so I would lean toward calling this one symmetric. I could see people making a case that it's slightly skewed right because you might include 1 in the cluster. You can see that there's a little less on the right side. So it could kind of you might take either answer here, but I think it's definitely more symmetric. When you look at number 4, I don't think it could be any more clear than this. This thing is like nearly perfectly symmetric. Not perfectly, but close. The cluster of the data is in the middle. The left and the right sides are almost equivalent. This looks like it's a frequency of 1. That one's a frequency of 2. It's pretty close there. Okay, so that's our data on shapes of distributions. Describing something as symmetric, as skewed right, or skewed left. You might need to turn the back at this time. On the back here, we have 2 frequencies tables showing the ages of people in a movie theater for a particular movie. We went with one from a few years ago. We got Frozen and we got Captain America. So if you notice here, this one is going to be a histogram from last section because we grouped the ages together. So we have everyone from 0 to 10 and then how many there were, 11 to 20, how many, etc. That made a lot more sense than creating a bar graph with every individual age differently. That would be a whole lot of bars in the bar graph. So your job right now is to make a nice, perfect looking histogram for each of these separately. So at this point you should pause this video, spend the rest of the page constructing your histogram, and then unpause it in a minute. Alright, we're going to say welcome back here. Hopefully you did that. And I'm going to jump to the answer here because I already done it. Okay, kind of sketch it out here. So we have over here, we have our movie Frozen. We put our title in, we have our labels, we have our histogram, sketched in. Over on the right, we have Captain America, and we have our histogram created. On the bottom, there are three questions which we're going to answer right now out loud. Number 6A says, after creating the histograms, answer the following questions. And it asks you to describe the shape of distribution for Frozen. And if we take a look at the shape of distribution for Frozen, I think clearly the cluster is lying over here. So for this one to be centered, it needs to be skewed over to the right. So we're going to skew right. It asks you for the shape of distribution for Captain America. And I think that one's pretty clear that the cluster of the data is toward the center. It's pretty symmetric, and the low end and high ends are pretty close. So that one would be symmetric. So this one, yet again, would be skewed right. And the other one would be symmetric. And I think that makes a lot of sense for what you probably know about those movies. That Frozen drew a younger audience, and Captain America kind of drew somewhat even audience. Which movie drew the younger audience there for number 3? Clearly it's Frozen. And you can describe a few reasons how you know. One, you might just know about the movie, but based off of the data, you would know because it is skewed right. You could also write that the cluster is on the left. So we're looking for you to use some of your vocabulary words from this chapter to help you out here. So that's it for 10.3 on shapes of distributions. We'll see you in class.